Hello, my name is Ross Overstreet with FLIR here at the Photonics West show. I want to talk to you a little bit about high-speed infrared applications today. FLIR has a new line of cameras, the XSeries, that are our fastest cameras released to date. We have the X6900, which is a 1,000 frame per second 640 by 512 pixel camera, and we have the X8500, which is a 1280 by 1024 pixel 180 frame per second camera. These cameras are producing data so quickly that you can no longer fit it down a gigabit Ethernet cable and get it back to a PC. With previous camera designs, we had to utilize a high-speed data recorder to capture this data. These cameras are unique. The X-Series is unique in that it has high-speed RAM built into the camera, so we can save up to 26 seconds of data at the maximum frame rate on board the camera. In order to get the data off the camera, we can stream it at slower speed down gigabit Ethernet, or we can copy it to a removable solid-state hard drive and use this to quickly transport the data. Now, I mentioned the full frame rate capabilities of the cameras. It's important to note with this type of detector, the cooled photon counting camera, we can window the camera down and go even faster. For instance, with the 1,000 frame per second X6900, we could window to half the height and go at roughly twice the rate. So I could do 2,000 frames per second at half the window height. If I half it again, I could go about 3,800 frames per second. As far as applications, we are seeing a lot of customers use these cameras for things such as airbag testing, especially with some of the concerns that have been around the industry with particles coming off and things like that. We can watch the airbag fully inflate, see the gas come off the back, and if any small particles or fragments leave the airbag, we can see those very well in infrared. With a visible camera, when you have an explosion or something coming apart and throwing pieces at a high rate of speed, sometimes you don't get a lot of contrast because the projectile may have roughly the same color as the background, so there's not a lot of visible contrast. With infrared, typically these parts are hot, either from the initial explosion event or from mechanical work, and they have a lot of contrast and they stand out really well. Other interesting automotive applications are tire testing or brake and rotor testing. These cameras have very short integration times, so they can effectively stop motion of fast-moving things. And we can accurately measure the temperature on something spinning fast, like a tire at 140 miles an hour. Also for aerospace applications, we can see aerodynamic heating on flight surfaces. For example, we can look at helicopter rotors, freeze the motion, and see the heating on the tips of the rotors. We have a number of customers using these cameras for combustion analysis, where they're looking down into a cylinder and watching a flame propagate inside of a cylinder, or possibly seeing temperature on various cylinder walls and piston surfaces and things like that. We use these a lot at the military test range for things such as target scoring. So you have a projectile coming into a target, it hits the target, and fragments leave the explosion. We can see those much better in infrared than you would see in visible. So that's just a short collection of areas where we use high-speed infrared.